Hello folks. Well, this time I want to talk about debugging for specific languages. So, there's always the generic ideas on what we should do, but I want to take a look at just discussing things to consider when you're working with any language in particular, whether it's C or C++ or Java or Python or Bash or whatever it might be. Most languages have some features that will help you debug that particular language. So it's useful to investigate that right from the beginning. Most of the time, these are going to boil down to kind of a handful of different ideas. Either you've got special variables that are available that have some key debugging information in them, or there's special functions, possibly in special libraries that you can include and use, or there might be special options that you can configure with respect to debugging for that particular language. So we'll look at examples specifically for C, C++, and Bash. And I just want to talk about some of the possibilities. So for C and C++, one of the things that's handy in terms of just displaying relevant information in debugging statements are a bunch of hash-defined variables. So you can use these from anywhere in the code. They're automatically hash-defined. And for each of these, the format is 2 underscores. So again, that's 2 underscores there, not one big one. 2 underscores, a name, and 2 underscores. So the one that's file contains the name of whatever file it happens to be in at that point, whatever C++ file or C file it happens to be in. And similarly, 2 underscores and line 2 underscores gives you the current line number. So if you've got a cout or something like that, you can see out, okay, we're in file blah on line whatever. Similarly, things like time and date will give you the current time and date when the print statement is executed, or when you use that. So again, you can dump these into strings, you can print them out, you can do whatever's useful with them. And again, those are double underscores on each side. So you can stick those directly in the code. You can stick in a statement that says, okay, we're on line blah in file blah, or and at time blah on day blah. So those can be handy if you're just spewing out information about what seems to be going wrong or going on in a chunk of code. Another thing I wanted to talk about was the idea of the assert statement. So for asserts, you're basically sticking a line of code in your program saying, I think at this point in the program, blah must be true. If it's not true, something's gone horribly, horribly wrong. So what assert does is checks whatever condition you're asserting, and if that condition is false, it says, uh-oh, this is something critical. It shuts the program down immediately. So the program exits, and it displays a message along the lines of assertion failed, and it shows you the line of code for the assert and what line number it's on, and I think what file it's in. So this is a way of shutting the program down and giving a brief note on why at any point. So essentially a failsafe for cases where this isn't meant to be for error checking. This is meant as sort of a last line of defense before something actually blows up. So you should still be doing all of your normal error checks to say, okay, the pointer shouldn't be null, blah, 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 blah. But we can stick in our assert as one more safeguard someplace to say, okay, well, if I get here and that pointer really is null, or that value really is 0, or whatever it might be, again, something's gone wrong. The program is probably bugged. We need to go back and fix it. So that's what this is used for. Right? It's not for just general error message handling. So to use it, you use cassert or assert.h for if you're in C. So you go through, include the right library, and just stick assert and whatever condition it happens to be. So, assert my pointer isn't null. And again, if my pointer is null, the program terminates right there and then with an error message. And again, we don't want to rely on this just as a general error handling technique. This is a last gasp, something's broken. So usually the idea is we want to turn off asserts in the final version that actually goes out to the user. You don't want your program, well, you don't want it to get to the user that buggy anyway, but if it's running for the user, you don't want a program to suddenly end and say, give some weird termination message saying, x foo is not equal to 27 or something like that. You don't want some weird message popping up for the user. So you want to get rid of that stuff before it actually gets to the user. So hopefully you can get your program debugged before it goes out, turn off your asserts, and compile it, and hopefully everything is going to be nice and happy for your user. Now we don't want to actually go through and comment out all these asserts or actually delete them from the file, because if we change something later, we might want to turn them back on so that we can actually use them. And anytime you're going through and editing your file to remove lines of code or comment out lines of code, there's a chance you're going to break something unintentionally. So instead, G++ has a flag that we can use to say, okay, when you compile, turn off the asserts. So you can use this flag dash dn debug, right? Do not debug. So G++ dash dn debug, whatever your other flags are, and it'll go through and compile it with the assertions turned off. So really useful technique, something I recommend. I think that was everything I wanted to flip through for the C++ side of things. Again, make yourself aware of what your language provides for you. So we want to go ahead and do the same sort of idea for Bash, let's say, just to give a completely different example. Right, when we're going through and debugging our Bash scripts, we've got obviously all sorts of joyous issues to deal with when we're debugging Bash, as I'm sure you've discovered by now. So I wanted to look at a few of the options that are supported there. Now, usually we don't have debuggers for interpreted languages to the same extent as we do for compiled languages, because the idea is you can run these things interactively and sort of see command, result, command, result, command, result. And so one of the things that Bash provides are a set of flags that can let Bash display a command and then execute it, display a command and then execute it, so that as your script runs, you can see, okay, it's running this command, and then you can see what happens. Okay, it's running this command, and then you can see what happens. So the flags are this -xv, so examine what's going on, and basically a verbose mode. So you can do something like this to run it for the entire script, or you can turn it off if there's just one chunk of code where you want to turn this on, and then after that chunk of code, turn it back off again. You can use set-xv to turn it on, and set +xv to turn it off. So you can use these flags, just wrap them around whichever chunks of your code you want to have a look at. And again, if your script is crashing or doing something really weird, you can get a closer look at what's taking place for that chunk of code. The other one I wanted to mention was -u, that you can use the same way. So you can say, -xvu if you want. And this just turns on checking for the use of unbound variables, variables that don't have a value associated with them. Right? So if you've declared a variable and not set it, or if you've grabbed it from a parameter that doesn't exist, then it might be useful to know. So again, this just gives us a warning that you're trying to use an unbound variable in the middle of your script. Just handy things to play with. There's also a trap option in Bash. And basically for trap, you can say, it's kind of like a catch where you're saying, on this condition, I want to do this. So you put in a trap statement in your Bash script, and then you say, I want to do, and then whatever the next command is. So here I've just got it doing an echo. Oops. I've got trap, echo. I'm missing a keyword at the end here. Hang on. So I want to trap and do this under, and then you're supposed to have a condition out here on the right-hand side. So if I want to print this anytime the script exits, so whether it crashes or whether it exits from some point in the middle of the script or whether it gets to the bottom of the script and exits, then I put in the keyword exit out here. And wherever it is that the script stops, it prints this message. So for instance, if I want to print whatever x is at the point where the script ends, I can do something like this, right? Do this command on exit. And so it's just uppercase the word exit. You can also throw in things like debug and other signals that it can catch. exit's probably the most common. Let's see. The other thing I wanted to take a look at was the idea that even if our language doesn't directly support something, we can build in our own support for particular actions we want. So we were talking about asserts in C or C++. We could do something similar in Bash where we say, okay, well, let's write an assert function that checks if a condition is true, and if it's not, then we'll exit with some status value. So I'm going to write a little assert function here that expects two parameters, a Boolean condition, and then a status value. If the condition is false, I'm going to exit with that status value. Otherwise, I'm just going to let the program plow right on ahead. Right, so if I was going to use something like that, then I would simply say assert, and then I'm going to stick my condition in a string here. So assert whatever, and then whatever status value I want to use. So if x is actually less than y at this point in the code, then assert's going to say, oh, well, that's true. We can go right on ahead. But if x is greater than or equal to y, it's going to say, oh, that didn't work. And when we hit this, it's going to exit with a value of 1. So you can build in your own asserts or whatever other functionality that you happen to want. Okay, so we'll let you go back to the joys of debugging Bash.